Example 5 in Stat 101, Examples Class 4, tree diagram, backpackers example. A bus company transports backpackers around New Zealand. Experience shows that 60% of their customers are English, 30% are American, and 10% are Canadian. The proportions from each of these places who are women are 4/5, 3/5, and 2/3 respectively. Our question is, if a backpacker chosen at random is a woman, what is the probability she is English? Defining our events, first of all, event E will be the backpacker is English. Event A, the backpacker is American. Event C, the backpacker is Canadian. And our other event is W is that she's a woman. We will need to use the conditional probability formula because the question has the word if. So it's given a backpacker chosen at random is a woman, or if a backpacker chosen at random is a woman. It's a conditional case. So this time, is it probability of English given woman, or is it probability of woman given English? The question asks, if she is a woman, what is the probability she is English? So it's going to be the probability of English given that she is a woman. We know she's a woman. That's happened already. What is the probability then she's English? So probability of English intersection woman divided by probability of woman itself. Just modifying the conditional probability formula you'll find on the Stat 101 webpage. This good example for a tree diagram, splitting it into two stages of the tree. Our first stage is where the backpacker is coming from. We've got a choice of English, American, and Canadian, so we will have 3 branches on this first stage of the tree. Probability that she's English, probability that the backpacker is English, probability that the backpacker is American, and probability the backpacker is Canadian. These figures from the question are probability English of 0.6, probability American of 0.3, and probability Canadian of 0.1, which completes the first stage of our tree. Just transferring across to looking at the second stage of the tree. The second stage of the tree being, is the backpacker a woman or not a woman? So probability they're English, probability they're American, and probability they're Canadian, followed by the next stage of the tree. Are they a woman or are they not? So these are conditional probabilities. Probability of woman given that they're English. And we're given this in the question as 4/5. We're also given 3/5 that they're American. So probability woman given American will be 3/5. And the last bit of information given in the question is the probability that they are Canadian, woman and Canadians. Probability of woman given that they're Canadian is 2/3. Because the probabilities of both pairs of branches must add up to 1, total probability must be 1, of course, we can fill in the remaining probabilities that are missing from our tree. So probability they're not a woman given they're English, probability they're not a woman given they're American, and probability they're not a woman given they are Canadian. The 2 probabilities for each pair of branches summing to 1. Looking again at that conditional question that we were asked, probability they're English given woman, probability English intersection woman dividing by probability of woman itself. Just our modification of the standard conditional probability formula. The top line will be probabilities English intersection woman, but the bottom line we must find out the total probability of being a woman. Which paths on our tree lead to the total probability that our backpacker will be a woman. Could be a woman given that she's English, a woman given that the backpacker is American, and a woman given that the backpacker is Canadian. Summing up those three branches will give us the total probability that the backpacker is a woman. So probability of the English intersection woman. The top line is 0.6 times 4/5. The second one, probability that they're American intersection woman, will be, remembering, multiplying across the tree diagram as we go from left to right. So picking up those values for probability of American intersection woman. So that will be our probability that they're American of 0.3 multiplied by that conditional probability that it's a woman given that they're American, multiplying by that 3/5. So a total value there of 0.18. Third branch we're looking at, probability that it's a Canadian intersection woman, will be the 0.1 that it's probably Canadian multiplied by the 2/3, the probability that it's a woman given that they're Canadian, leading us to a value there of 1/15. So the total probability that it's a woman is the probability of English intersection woman added together to the probability of American intersection woman added together to the probability of Canadian intersection woman. So adding together those three outcomes, 0.48 added together to the 0.18 added together to the 1/15. Total probability of a woman, 0.727 to 3 decimal places. So these are the steps, just working out the numerator and the denominator of our conditional probability formula. Now we have those, transferring those across. Probability of English given that it's a woman is the probability of English intersection woman. That's our 0.48. Divided by that total probability of being a woman of 0.727. The answer being 0.66 to 2 decimal places. So the question, if a backpacker chosen at random is a woman, what is the probability she is English? The answer, 0.66 to 2 decimal places. And that's the end of example 5.